All right, we are about halfway through our Excel DSS project, and in today's presentation, all you need is your Excel DSS project file and just follow along with the video. There'll be just a few edits that you'll need to make. In the video, we'll explain the different areas of the regression analysis, and it shouldn't take too long. All right, looking at our regression analysis, we'll take a look at the first area here, and we're going to focus on R square. In fact, if you want, you can highlight R square with any color you want. I'm going to choose a nice green here. So I'm just highlighting R square, and R square is the goodness of fit or relevance of the model. For this project, you want an R square that is greater than 50% or 0.50. And what you see below is an example of how we get the R square or how the R squared is determined. So let's say below you have a chart here of a young child practicing the piano. And along the x-axis, along the bottom is time, and on the y-axis is performance, or how well he or she is done. So they start off here in the beginning, and I'm going to grab a little marker here. They start off here in the beginning, uh, so the time is low or short, and their performance on the exam or the audition is poor. As time goes on and they practice more, they perform a little bit better and better and better. And so by the end of the month or 2 months, their performance and over time is much better. If I were to draw a line here, you can see that these points are relatively close to the line. You can see that there is a great improvement, and this model of time over performance is a pretty good fit. So this is what like an R square of 90% looks like. Here's an example of the same student, or actually, let's say it's a different student, and they're practicing the piano, but as we plot their performance over time, you kind of get this random pattern. And so we certainly can't draw a line like this because that's not what these numbers are saying. Uh, in this case, it's sort of flatlined, or anything you kind of draw really doesn't make sense of this pattern. So this is a very low R square. This is a poor fit model. So the R square would certainly be lower than 50%. So back to our spreadsheet here, our regression analysis. My R square is 0.777, so 77%. So that's a pretty good model. I can move forward with this. If it's lower than 0.50 or 50%, you may want to go back and throw out a competitor or throw out a variable too and replace it with something else, and then run the regression analysis again. But as long as this is above 0.50, you can move on to the next area. So let's move down to this next area here, p-value. I'm going to highlight p-value in this light blue. You can color it any color you like. The p-value is a figure that represents the likeliness of chance. Is the predictor variable, does it have a real effect on the dependent variable, or is it just sort of a random occurrence? The lower the p-value, the greater the relationship or the more real it is. The higher the p-value, the more likeliness that it is a random occurrence. So let me explain a little bit further. So imagine you are at a basketball game and your friend who isn't usually good at shooting makes 9 out of 10 shots. And you start to wonder, has my friend gotten way better, or was this just a lucky streak? So when you're looking at the p-value, you're looking at the likeliness that what your friend did out there on the court was by chance or random. So the smaller the p-value, the likeliness that it is not chance is that it is significant. So you run an analysis, and let's say you come up with either one of these two results. If the analysis you run comes up with a small p-value, that means it's very unlikely that your friend made 9 out of 10 shots by chance, so that he may actually have improved his shot. If you have a large p-value, that means it is quite possible that he made 9 out of 10 shots by luck. He basically closed his eyes and threw the ball up, and 9 out of 10 times it just so happened to hit the mark. So a small p-value means the result is unusual but likely real and not just luck. Going back to our regression analysis, let's take a look at these p-values on the regression analysis. And you'll notice that a few of these have this E embedded in the number. That's an exponent, and with the negative number afterwards, that is the number of zeros in front of this number. So looking at the Sam Adams volume variable here, it has a p-value of 4.56316 E negative 11. This number looks like this. I'll type it out. Okay, so it has 11 zeros in front of the 456,316. And if I hit enter, you can see that this number and this number are exactly the same. So what you're looking for is significant. The likeliness that the predictor is significant. So you really want to find these numbers here that have a very high E negative number. So the most significant one here is corn. All right, so I'm going to highlight corn. I'm going to highlight this in, I'll do an orange here because it's E negative 97. So there are 97 zeros before it is, you see the 6.31 or the 63169. Another big one would be Constellation, I believe that was the name of the company. All right, because that's E negative 55. So there are 55 zeros. Another one here would be wheat. Okay, so that has a very strong likelihood that there is a significant relationship between the variables here and the price of the Sam Adams stock. E32, that's pretty significant. E27, that's pretty significant. You don't have to highlight all the ones with the E's. You should just get, maybe the top three or four that seem pretty significant. So in this case, wheat, corn, and the price of Constellation seem to be pretty significant, whereas um, the price of Molson's is up there as well, as is oil. Surprisingly, Budweiser has a very, a, I guess, a weak correlation to the price of the Sam Adams stock. So this is your P value. Now we're going to look at the coefficient. I'm going to highlight coefficient in a different color. Again, you can use any color you want. It could be all the same color. I don't care. But let's focus on coefficient for 1 second. The coefficient in regression analysis tells you the direction and strength of the relationship between the independent variable and the dependent variables. And for this project, I'm really just concerned about the direction. I don't care so much about the strength. Um, so if you have a positive coefficient, it means that as the predictor value increases, the outcome increases. So when the price of the commodity of corn goes up, the price of our Sam Adams stock goes up. Okay, so that's positive. When one goes up, the other goes up. A negative coefficient means that the predictor variable increases, but the outcome decreases. So let's say and again, I'm just kind of pulling this off the top of my head. If the price of oil goes up, the price of the Sam Adams stock goes down. So there is a negative correlation or a negative coefficient. Let's take a look at this lemonade sales versus temperature. Maybe you get a better idea. So imagine you're helping at a lemonade stand and you notice that the hotter the day, the more cups people buy. The coefficient will tell you how much sales go up with each extra degree of temperature. So if the coefficient is +2, that means for every 1 degree it gets warmer, you'll probably sell 2 more cups of lemonade. So you'll get more sales on hotter days. But let's say you live in some weird bizarro world where you have a negative coefficient. So let's say -2. So that if the temperature goes up by a degree, you actually lose sales. You'll sell 2 fewer cups. So that is an example of a negative coefficient. So coefficient shows you uh, how much one thing affects the other and in which direction. Looking back at our regression analysis, all you really need to do is focus on whether these numbers are negative or positive. So again, I'm not worried about the actual number, the degree in which it is negative or positive. We're just looking for just the whether it's positive or negative. So here's an example. Oil is -7 or just negative. So when the price of oil goes up, the price of the Sam Adams stock goes down. Corn is positive. So when the price of corn goes up, the Sam Adams stock goes up. And here's a great example. TAP, which is Molson. When the price of Molson's goes up, the price of Sam Adams goes down. And then the opposite is true. If the price of the Molson stock goes down, the price of the Sam Adams stock goes up. So you'll see that there are negative correlations between 2 of the 3 competitors and 2 of the 3 commodities. But what you'll be focusing on is probably these that are highlighted in orange because they have the most significance to the price of your stock. So let's delete this number here. You don't need that. And we could move forward onto the next video.